Okay, so in this video, we are going to cover correlation. And I want to start off on slide 8, our decision tree, and point out that this test, if you want to call it that, or the statistic on the bottom left, correlation, this is when we are using a correlation. So with a correlation, we need to have quantitative variables. So if the variables that you are looking at are both numerical measures of something, then and you just want to see if they are related, you're going to use a correlation. So you see this branch all the way on the side here. Now a correlation, the symbol for a correlation coefficient is R, lowercase r. The whole purpose of this, it tells you if there is a significant relationship between two variables. Now, neither variable is considered an independent variable or a dependent variable. There's no predictor outcome relationship that's being assessed here. We are simply looking at, are the two variables related? Like I said, both variables need to be quantitative, typically interval or ratio level. However, sometimes ordinal data can kind of be transformed into numbers, and you can use ordinal data in this way. But yes, your two variables need to be quantitative, kind of like height and weight, or hours spent studying and exam grade, things like that. We are not working with categorical nominal data here. Okay, so the values that you're going to pay attention to, obviously R, that is your correlation coefficient. R tells you two things. It tells you the strength and the direction of the relationship between your two variables. Now the strength, let's talk about the strength first. The strength is assessed by the number in R. So you're going to ignore the sign, ignore the negative or positive, and just look at how close is the number to 1.0 versus 0. 1.0 is the largest possible correlation that you can have. Think of it as 100%. They're 100% perfectly correlated if you have an R of 1.0. That is the strongest possible correlation. 0, on the other hand, that is the weakest possible correlation. That means that there's no correlation whatsoever. Now let's talk about the direction. So the strength is just the number, 0 to 1. The direction is the positive or negative sign. So a negative correlation, that means that if one variable is increasing, the other one is decreasing. So for instance, number of alcoholic beverages you had the night before an exam and your exam grade. That would probably be a negative relationship. Whereas a positive relationship, both variables increase together and decrease together, such as the number of hours you studied for an exam and your exam score. Those would increase together and decrease together. So that is your direction. So if I'm asking you to identify the strongest correlation, you want to ignore the sign and pick the number closest to 1. If I'm asking you to identify the weakest possible correlation, you're going to ignore the sign and focus on the correlation that's closest to 0. Now, statistical significance is something that you can add alongside a correlation coefficient. This will tell you if there is actually a relationship. So correlations that are close to 0, they might not be exactly 0, but they're really small. Typically, those are going to come out as insignificant, meaning there's really no relationship that's worth paying attention to. To get a little more sophisticated on you, that would tell you that if you had full population data, you had data from every single person, place, or thing in your group of interest, there would be no correlation. So if you have an insignificant correlation, if you have a significant correlation, that is telling you that there really is a relationship. It doesn't tell you about the strength necessarily. It just tells you, yes, there is some kind of relationship, or no, there is not. And how do you determine if your correlation is significant? You look at the p-value So you might remember the p-value from QBA 283. This p-value comes from regression output. So it's a test, to figure out, it's a hypothesis test to figure out if there is a relationship in the population of interest. So the p-value, you might remember the rule, if it's less than 0.05, that's kind of a good thing. If you have a p-value of less than 0.05, that means there is a relationship. So there is a statistically significant relationship. If the p-value is larger than 0.05, that will tell you there's no relationship. So smaller is better. I'm going to get more into p-values and refreshing your memories on p-values and hypothesis testing in the regression video. So that will be coming up next. A few example correlations for you. I want to kind of test your thought on this. What do you think is the correlation between height and weight? So first guess, is it positive or negative? You would probably guess that it's positive because as someone gets taller, they probably weigh more. Now, it's not a perfect 1.0 relationship because you can have some really tall, thin people and you can have some really short, heavy people. But there is a relationship there. It's actually positive 0.44. What do you think is the correlation between satisfaction with your manager and tenure at an organization? So again, you might guess a positive relationship because the more satisfied with your manager you are, the more satisfied you are with your manager, the longer you would probably stay at your company. Whereas, vice versa. But there are a lot of other things that impact whether you stay at your organization, not just the satisfaction with your manager. So you get about a 0.39 positive correlation there. What is the correlation between scores on graphology tests, that's a handwriting test, and performance, job performance? 0.01, that is essentially a non-existent relationship. There is no relationship between handwriting and job performance. I guess unless you're a calligrapher, but assuming that is not the case. Okay, so what are the various strengths of correlations? What is considered a strong correlation versus a moderate correlation versus a weak correlation? So this comes from an article by Evans in 1996, and I think most statisticians would generally agree with this. So a correlation of 0 to 0.19 would be considered very weak. 0.2 to 0.30 would be considered weak. 0.4 to, once you get into 0.4s and above, that's whenever you're typically getting your statistically significant relationships. So take a look at these ranges here. Now, in the business world, you are usually going to see moderate relationships if there is a significant relationship between your variables. Very rarely in practice did I see anything in the strong or very strong levels. So, even sometimes in the 0.3s, those might come out as significant. And that just means that there is a correlation, but, it's just not perfect. So there you go. Okay, how do we actually get a correlation? There are lots of ways to do this. In Excel, there are 3 ways that make it quite simple. There is a function that you can type in Excel, correl, so equals CORREL. That will give you the correlation. In parentheses, you highlight all the data from your first variable, comma, and then highlight all the data from your second variable. So I'm going to go ahead and open up the data set that is posted on Canvas. It is called Data for Excel Data Analysis Tutorial, and this is it. And this is just some example like survey, HR data, and you're actually not going to see these columns in there. It's going to look like this. So in this first column, we have manager training. And each row here is data from an employee, a different employee. It's a pretty big data set. We have 693 employees data here. And this manager training data, this is, did their manager go through training? Yes or no? Ones are yeses, zeros are nos. Column B, this is the function that the employee worked in. So sales, finance, HR, or marketing. These were 3 survey questions that they were to fill out about their managers. So does your manager show trust in me? Does your manager communicate what is expected? Does your manager care about you as a person? And then are you happy versus upset with your job? Larger numbers are more favorable answers. So this first person, for instance, their manager did go through training. They work in sales. They rated their manager a 4 out of 5 on shows trust, a 3 out of 5 on communicates what is expected, a 5 out of 5 cares about me as a person, and then this person is a 7 out of 7 on happiness with their job, and a 2 out of 7 on upset. So that's the data set we're going to be working with throughout these stats review videos. So let's do the CORREL function. So in just any cell, you're going to type in CORREL. And let's correlate happy and upset, because we do think that that would be a negative relationship. If they're really happy with their job, they should not be very upset. So I am going to highlight the data under happy. Do not include the label at the top. Then I'm going to put a comma and then highlight the data under upset. Again, not including the label at the top. Close parentheses, enter. So our correlation between happy and upset is negative 0.82. Okay, so the second way that you can do a correlation, and this is really useful, is the correlation matrix using the data analysis tool pack. Now, the thing about a correlation matrix, it can give you correlations amongst all of the variables that you have in your data set. So what you might want to do, any variables that you want correlations between, put them side by side in your data set. Kind of like what we have here. So we're going to get correlations between all of these variables here. Now you will need the data analysis toolpack add-on. If you have the Nichols version of Excel, you will have this for free. So the way to get it is to go to File, Options. This is going to pop up. You're going to click Add-ins. You're going to click this little Go box and make sure Analysis Toolpack is checked and click OK. Then you're going to go to this Data tab up at the top and you're going to see this Data Analysis button. Now, if it's still not there, try closing out Excel altogether and reopen it. If you have a Mac, the steps are going to be a little different. You can try Googling how to add the data analysis toolpack on a Mac, and the steps should be really easy to find online, or you can email me for assistance. So let's build this correlation matrix. So data analysis is what I'm going to click. And then you're going to see correlation. These options are all in alphabetical order. So it should be one of the top options, correlation. Click OK. Input range, you are going to highlight all of your data in one swoop, and you are going to include the labels at the top. So it all has to be highlighted together. You are going to check labels in the first row. If you don't, you'll get an error because you need to tell Excel that that first row was not actually data, it was the names of your variables. So that's what that checkbox does. And then you're just going to click OK. So you will see here you have all your correlations. So you're going to see, let's talk about how to read a correlation matrix for a bit. You're going to see these ones. Now the reason why you have ones here is take a look at the variable labels. show trust in me, and show trust in me. So the correlation between that column and itself is 1.0. This one communicates what is expected of me and communicates what is expected of me. So that's just the correlations of how they line up. This 0.3385, that is the correlation between show trust in me and communicates what is expected of me. Moving down, the 0.01, that's the correlation between cares about me as a person and shows trust in me, and so forth. So you'll recognize this negative 0.82. That's what we just calculated using the COREL function. That's the correlation between upset and happy. Now take a look at this matrix. Which two variables are most strongly correlated? That would be happy and upset. So that is our strongest correlation, negative 0.82. And again, you're ignoring the sign and just looking at the number that's closest to 1.0. And of course, in that question, I was excluding all of these ones. What is the weakest correlation in this data set? It looks like that would be this one, 0.005. And that is the correlation between happy and cares about me as a person. So that's how you do a correlation matrix. The third way I'm going to show you is actually by running a regression using the data analysis toolpack. Now, we haven't covered regression yet. We're going to cover regression in the next video. But I'm going to go ahead and show you just how to do a regression. It's really easy, and where to pull the correlation coefficient from. The great thing about using the regression for a correlation is that you can get a significance value, that p-value. And the p-value will tell you if there is actually a significant relationship between your two variables. So that's the big advantage. This is my preference because I like to know, is that relationship significant? That's critical information. So to run the regression, we're going to use the data analysis toolpack again. So we're going to click the data tab, data analysis, and you're going to choose regression. Then it's going to ask you for an X range and a Y range. If you are simply just looking at a correlation, it doesn't matter which variable you put as X and Y. If all you want is a correlation and the significance. You are going to check labels as well. So let me show you that in Excel. Let's do the correlation between happy and upset again, but using that regression option. So I'm going to go to data, data analysis. I'm going to scroll down to regression. I'm going to click OK. X range, I'll put as happy. So I'm going to start with happy here, go all the way down. And then for the X range, I'm going to do upset all the way down. I'm going to check the labels box and click OK. Okay, so here, where you see multiple R, let me blow this up a little bit. Where you see multiple R, that is our correlation coefficient. However, you might notice something is missing. It should be negative. So that's one thing to look out for. This only gives you the strength. It doesn't give you the sign. So how can you get the sign? This value down here, the negative 0.83, that is the slope between the two variables relationship. It's negative. So that is how you know the correlation should be negative. So our correlation from that is negative 0.82, just like we got with the COREL function. Now the p-value you can find in two places, here or here. Now make sure you know this if you're going to be working with Excel, which you will in this class. Anytime you see e to the negative whatever, that means you move your decimal place to the left that number of times. So we are moving our decimal place to the left 171 times. This is a really, really small number. It's practically zero. That p-value you are comparing to alpha. Compare p-value to alpha. Our p-value here is definitely less than alpha, which is usually 0.05. So when our p-value is less than alpha, we are going to say there is a significant relationship. Okay, so that's our conclusion. So just some little notes here for you. So we're comparing that p-value to alpha. Alpha is typically 0.05. So our p-value is less than 0.05, which means there is a significant relationship. And it's so strong. I mean, negative 0.82 correlation, that's pretty close to 1.0. So I'm not surprised that the p-value is really small. Okay, now everything I just showed you is on this slide. So yeah, this is the regression output, just an image of it. We have our correlation. This is our sample size where you see observations 693. We had data from 693 people. The symbol for sample size is N, lowercase n. And then I point out you have to look at this sign right here and this p-value over here. Now, how do you write up a technical report of a correlation? Use this as a template anytime you need to write up a correlation in a report. You're going to say something like a correlation coefficient was computed to assess the relationship between your first variable and your second variable. So in this case, happiness ratings and upset ratings. There was or was not a significant negative correlation between the two variables. So you could have insignificant or you could have positive. Just, make sure that aligns with your results. In brackets here, you're going to put lowercase r. And I think that should be italicized. Equals. Here's your correlation coefficient rounded 2 places past the decimal point. Always just round 2 places past the decimal point. Comma, n. That's our observations in our output. So n is 683, comma, our p-value, you only need to say if it's less than or more than 0.05. You could put 0.01. 0.01 is also a commonly used alpha. If you want to be a little more conservative, you can use 0.01 or even 0.001. But you don't need to report the exact p-value, just p is less than 0.05. And that p should be lowercase and italicized. So that's how you write up the results. You will have to do that for the projects. So yeah, get familiar with it. And that wraps up the correlation video.